Elimisha, Msichana, Elimisha, Jamii na Astronomia, which is Swahili for Educate a Girl, Educate the Entire Community with Astronomy, is an OAD funded project that is promoting the education of girls in rural Kenya through several social programs. Most girls schooling in rural areas do not complete secondary education due to various socioeconomic challenges such as early marriages, poverty, female genital mutilation, and lack of role models for these girls, and also teenagehood pregnancies, which is a major issue. So we trying to tackle these socioeconomic issues through this program. For example, through astronomy outreach, this EMEJA program is providing leadership and mentorship to young schoolgirls in their final year of primary education. And this is achieved by engaging the local communities, that is the girls themselves, the students, the teachers, and the parents, and all the relevant stakeholders in education, whereby we discuss ways to positively tackle these socioeconomic issues to ensure that these girls get to complete secondary education. This is then followed by long-term tracking and monitoring throughout high school, where each mentee is paired with a lifelong mentor. We're also providing tuition fees, scholarships to some of our mentees from economically disadvantaged backgrounds and who would otherwise fail to enroll for secondary education due to lack of tuition fees. So through the AstroSTEM workshops and mentorship, we aim to encourage early participation of girls in STEM, and to also fight these misconceptions about STEM among young schoolgirls. And this program is aimed for girls in years 1 and 2 of secondary education. So through the AstroSTEM, we're also providing the target schools with some of the critical but missing infrastructure, such as basic laboratory equipment. For example, in our previous AstroSTEM events, we provided some of these schools with basic equipment, such as multimeters, tubings, and bulbs and wires, everything else. So computer literacy is non-existent in these regions. Therefore, we are introducing these students to computers and sponsoring some of the schools with computers to encourage computer learning. For example, before AstroSTEM, we asked how many students had used computers, and 86% of them said they'd never used computers before. And these are students, girls aged between 14 to about 18 years old. So the impact so far, we've reached out to almost 2,000 girls, both in primary schools and secondary schools. And we also engaged with several local primary schools, I think about 20 of them, and about 5 secondary schools. And also engaged with the local teachers and a number of mentors and AstroSTEM tutors. So this EMEJA program is contributing to some of UN Sustainable Development Goals, such as quality education, gender equality, reduced inequalities, and indirectly to others such as good health and well-being. So to summarize, the main objective for this program is to ensure 100% transition between Kenya Certificate for Primary Education and Kenya Certificate for Secondary Education for these girls. So through this OAD funded project, we carried out astronomy outreach and events, as illustrated in the previous slide, whereby we engage with the local communities, including parents, teachers, students, in discussing ways to, again, positively tackle some of these issues that hinder education of girls in these regions. So through the long-term tracking and monitoring program, we hope to increase the number of girls completing secondary education. Additionally, one of the key objectives for this project specifically was to change STEM misconception among young schoolgirls and to also encourage early participation of girls in STEM subjects, and I believe we achieved some of these. We also aim to create resources for these schools, such as laboratory equipment, and also introduce these students to computers. So our main deliverables included the AstroSTEM workshop, which were 2-day events delivered through lectures, presentations, and direct engagement with the students. We also carried out teacher and mentorship programs through meetings and discussions with the students and the parents and the teachers. We also paired each mentee with a mentor. And then the other deliverable was tracking and long-term monitoring, whereby before every new academic term or semester, we phone each mentee plus their parent just to keep track of their progress through high school. And we also trained our mentors, tutors, and teachers remotely before we began all these activities. So some of our intended outcomes included improved grades in STEM subjects, whereby when we compared the average grades before and after AstroSTEM, there was a remarkable improvement in the average grades attained in physics, mathematics, and geography across all the 4 schools. There was also an increased number of girls selecting physics. For example, as seen in one school where we had 1 female student taking physics subject in year 3, but then after the AstroSTEM, 16 more girls requested to join the physics class. Teachers are also reporting changes in attitude towards STEM, with more girls getting involved in STEM activities across the school. And we also paired the class of 2020 and 2021 with the lifelong mentors. We also managed to contribute to increase computer literacy. For example, in one school before the AstroSTEM, we asked the students if they had used Microsoft Word before. We consider like Microsoft Word to be the most basic form of computer usage, whereby 86% of the students say that they never used Microsoft Word before. And these are, again, students aged between the ages of 14 and 18 years. We also asked the student to describe the solar system, and 86 of them could not really describe the solar system before the AstroSTEM. And then we asked the same question after the AstroSTEM. We can see a remarkable improvement to about at least 80% of the students could now describe the solar system a lot better. So some of the challenges that we've encountered in our delivery included lack of basic laboratory equipment. So we had to purchase some of the equipment for a hands-on experiment. We also encountered a large number of students than anticipated, with small ill-equipped laboratories. Therefore, we had to improvise. For example, we split the students into smaller groups and into smaller different sessions, which were quite effective, but it took a lot more time than anticipated. Of course, we delivered these activities during the pandemic. And again, cases of needy EMEJA mentees is greater than what we can offer, especially following the economic fallout precipitated by this pandemic. Lastly, one of the main challenges that we are grappling with right now is what happens now after the OAD funding comes to an end. How do we keep this momentum going and growing for a long-term impact? So many thanks to the OAD for making this project possible, and to Ramasamy for the seamless communication throughout the implementation of this project. You can find us on the socials. Just search for our handle at Elimisha Msichana. And thank you.